Hello, everybody. This is Bert Dixon here presenting on lesson 3.3, measures of position. And so the main measure that we use for position is called a z-score. And what the z-score tells you is circled right down here. A z-score tells you the number of standard deviations that a data value falls above or below the mean. So for example, you might have a data value that is 2.6 standard deviations above the mean, or 1.8 standard deviations below the mean. And so that's what the z-score represents. It represents a distance from the mean and proportional to the standard deviations. Okay, so if we take a look at example 1, on quiz 1, let's say you scored 44 and the class mean was 32. On quiz 2, you scored 28. The class mean was 23. And the standard deviation is given for both of those as well. The first quiz, the standard deviation was 8. And for the second quiz, it was 3. And so we want to know on which quiz did we perform better. I mean, obviously, a 44 is a higher score than 28. But relative to the mean, that is not necessarily the case. So we want to compare our score to the class and use that as a determination of on which quiz we did better relative to the rest of the class. So the z-score, the way we calculate that is the data value minus the mean over the standard deviation. And so in this one, it would be the data value minus the mean divided by the standard deviation. So 44 minus 32 is 12, divided by 8 is 1.5. So 1.5 standard deviations above the mean. Okay, now let's compare that to quiz 2. For quiz 2, we would do 28 minus 23 divided by 3. And so 28 minus 23 is 5, divided by 3 is 1.67, or we'll call it 1.7 standard deviations above the mean. By the way you can tell if a score is below the mean, then your z-score is going to be negative. So negative z-scores mean it's below the mean. Positive z-scores mean it's above the mean. So our z-score is 1.7, so we get 1.7 standard deviations above the mean. So even though your score on the first quiz was higher relative to the rest of the class, 28 is actually a higher score because relative to the mean and the standard deviation, it's more standard deviations above the mean. Okay, and then we can also, in terms of position, we can always talk about percentiles. A percentile tells you what portion of the population you are higher than, or your score is higher than. And so the percentile formula is the number of values below your current x value plus 0.5 divided by the total number of values, and then times 100. And so for example 2, if we're looking for the percentile rank of 86, we want to circle all the values that are less than 86. And so that's going to be all of these. Okay, so altogether I circled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. there were 19 values that were below 86, and then we add on 0.5, and then we'll divide by 24, because there are 24 scores in this table. So 19.5 divided by 24 is 0.8125. So we'll say that that is the 81st percentile. Meaning the score of 86 is higher than 81% of the other scores. We can also identify quartiles of a large data set. It basically divides the data into 4 groups of equal number of items in each group. And so the Q2 is just the median. And then Q1 is the median of the lower half, and Q3 is the median of the upper half. Okay, so if we go back to the data that we just looked at in example 2, if we put those in order, we'll do that over here in the margin. So we have 28, 31, 52, 58, 64, 65, 67, 68, 71, 72, 73, 75, 277s, and 82, 384s, and 85, 86, 87, 88, 89, 99. Okay, so there's our list of 24 items. So the middle, or the median, Q2, we would go to the, since we have 24 items, we would go to the 12th and the 13th. So there's 12, and so there's the middle right there. And so to find the middle, we would just average 75 and 77. So that is 76. And so our Q2 is 76. And now Q1 is going to be the middle of this lower half. And so there are 12 items here. So if we go to the 6th, Q1 would be down here, which is halfway between 65 and 67, which is 66. So Q1 equals 66, and then Q3 is the median of the lower half. So 1, 2, 3, 4, 5, 6. And so in between 84 and 85 is Q3, and so that would be 84.5. So those are the 3 dividing lines of the data. So we have the first group, the second group, the third group, and the fourth group. So essentially we've got 6 items in each group, because there were 24 altogether, divided into 4 equal groups. You're going to have 6 items in each group. Okay, and then from that we can calculate the interquartile range. So Q3 minus Q1 in this case, in this example, was 84.5 minus 66. And that is 18.5. So that's our interquartile range, IQR. Okay, an outlier is typically extremely high or extremely low value compared to the rest of the data. And so the way we calculate that is if we do Q1 times 1.5, Q1 minus 1.5 times the IQR, and we also do Q3 plus 1.5 times the IQR, then anything above the smaller one, below the smaller one and above the bigger one would be considered outliers. And so in this example, Q1 is 66, so 66 minus 1.5 times our IQR of 18.5. So that would be 32.5, or sorry, 38.25, 38.25. And then if we do this one, this would be Q3 is 84.5 plus 1.5 times 18.5, and that is 112.25. And so anything below 38.25 would be an outlier. Anything above 112.25 would be considered an outlier. So if we look at our data, there are no values above 112, but there are values below 38.25. So these two would be considered outliers. 28 and 31 are outliers. Okay, so they're very small compared to the rest of the data. Okay, so now you can take out your student notes for Chapter 3, go to the section that is labeled Measure of Position 3.3, and go ahead and work through until you get done with lab problem 4 and the 4 steps below that. Okay, so pause your video, work on that part of the student notes, and then press play when you're ready to continue with 3.4. And now with section 3.4, we're going to demonstrate how to do box plots, which is a way of analyzing and displaying data. And so when we do box plots, we need the 5-number summary, which includes the minimum value, Q1, the median, which is Q2, Q3, and then the maximum value. So once we have those 5 numbers, we have everything we need to generate a box plot. And so if we look at the data set here, the let's see, putting those in order, 0.51, 0.74, 0.89, 1.04, 1.18, 1.38, 1.41, 1.42, 1.45, 1.45 again, and 1.49. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So if we go 1, 2, 3, 4, 5, the 6th one is our median, which is Q2. And then we have 5 below. This is the median of the lower half. So that would be Q1. This would be the median of the upper half. That's Q3. And so now we have the 5 numbers that we need. Here's the minimum, and here's the maximum. Okay, so that's all we need in order to create a box plot. So notice our values range from 0.51 to 1.49. And so I'm going to use graph paper for this one. Okay, so I'm going to start at, I'm just going to put a number line up here at the top. I'm going to call this 0.5, 0.6, 0.7, 0.8, 0.9, 1, 0.0, 1.1, 1.2, 1.3, 1.4, 1.5. Okay, and so now when we do a box plot, our lowest value is 0.51 and our highest value is 1.49. And then Q1 is at 0.89, which is going to be right about here. So we're going to do our box right there from 0.89 to Q3, which is 1.45. 1.45 would be here. And then our median was at 1.38, which is about right here. Okay, so this is 0.51. This one was 0.89. Then this was 1.38 and 1.45. And so that is our box plot. And so that kind of shows you what the data looks like. We have kind of data is more spread out on the for everything below the mean, and then very compact above the mean, or the median, I should say. It's very spread out below the median for this data set and very compact above the median. Okay, so for example 2, we're going to use box plots to compare two different data sets. And so if I put these all, the wood items in order, 35, 48, 51, 56, 60, 67, 68, and 72. 1, 2, 3, 4, 5, 6, 7, 8 items. And so the median is going to be the average of 56 and 60. So that's going to be 58. So Q2 is 58. And then we have 4 items in our lower half. And so Q1 is going to be the average of 48 and 51. So that would be, sorry, that's 50, not 51. So the average of 48 and 50 is 49. And then the upper half, the average of 67 and 68. So Q3 is 67.5. And we have our min and our max. Okay, so that was for wooden roller coasters. They're the speeds of 8 different wooden roller coasters, and then the speed for 8 different steel roller coasters. The items put in order: 28, 48, 55, 70, 100, 102, 106, and 120. And so this is going to be 85. Q2 equals 85. Then the middle of the lower half is going to be the middle of 48 and 55. So that is 51.5. And then the median of the upper half is the average of 102 and 106. So that's 104. Okay, so now if we create 2 box plots, and put them side by side, then it makes it easier for us to compare the data for the steel roller coasters and the wooden roller coasters. Okay, so on my number line, I'm going to call this 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay, for wood, and this is average speed. So our minimum for this one is 35. And then we go to 44. And then 58. And then 67.5. And then 72. Okay, so we have a very compact box plot here. And then we'll do the same thing with steel. So our low is 28. $51.5. $104 would be about right there, and 120 is our maximum. Okay, so all right, so now we can see by comparing those box plots side by side, since the units are the same. This is steel roller coaster frames. So we see that there's a lot more variation in the steel, but the average speed for the steel is quite a bit higher than for the wooden frames. But there are some steel framed roller coasters that actually go slower than the wooden ones. So that's information that we can see just by comparing these two box plots side by side. Okay, so you should now be prepared to go on. One thing I didn't mark is usually put a vertical line right through the median on these. I don't know if I did that on, yeah, I did it up here. That is the median. And some box plots you'll see they don't put the line all the way through. They just put the, they call those stem and whisker plots. So you just put the whiskers on the ends. You don't need lines through the middle. So I could do that on these. It just kind of cleans it up a little bit so you don't have so much going on. But if you do put a line all the way down the middle, it doesn't really change the correctness of your box plot. So on the student notes, if you go to where the 5-number summary is, start there, and then go all the way to the end, which is just that one page, I believe. Okay, so you should be able to finish all of the student notes for Chapter 3 and then turn those in Canvas once you're done. Have a great day, everybody.